Methane is not ionic because the 4 hydrogen atoms and the carbon atom share electrons through covalent bonds instead of transferring them, and creating ions would require far more energy than the shared arrangement provides. Think of carbon and hydrogen like friends sharing a toy so both can play. Carbon has 4 toys to share, and each hydrogen wants one, so they each hold on to the same toy together rather than one taking it away. Sharing keeps each atom's outer shell more stable without forcing a full electron to move from one atom to another. And removing or adding an electron to make charged particles would cost a lot of energy that the atoms do not gain back. Covalent bonds form when atoms overlap their electron spaces and both feel more comfortable, while ionic bonds form when one atom gives an electron and both end up with full shells but as oppositely charged ions, which is not preferred for carbon and hydrogen in methane. Because hydrogen and carbon have similar tendencies to keep electrons rather than fully give them up or take them, sharing is the easy and energy-wise smart choice. Students often think that any bond is either purely ionic or purely covalent, but many bonds are somewhere in between and must be judged by how much electron sharing happens, so remember to consider electronegativity differences rather than only labels. Another common mistake is imagining electrons as tiny balls that sit only on one atom. Instead, picture a cloud where electrons are more likely to be found between the 2 nuclei in a covalent bond. And if you must choose a model, use the electron cloud idea. A short tip is to ask whether moving an electron would require a lot of energy. If yes, the bond is likely covalent rather than ionic. For more videos and resources on why methane is covalent and not ionic, check out www.gumballdegree.com.